Alright, let's review for the test tomorrow. Ohm's law. Does anyone remember the equation for it? I remember Ohm's law using the acronym VIR. Voltage is equal to current times resistance. It is technically, however, current is equal to voltage over resistance. So if you remember VIR, so V equals I times R, solve for current, voltage over resistance. So you'll need to remember Ohm's law. So what is conventional current? So what's the hello? Alright. So what's conventional current? So if I have a simple circuit, just a battery, so just a battery and a resistor, we can see electrons moving. Electrons are moving out of the negative or short terminal clockwise, but if I show conventional current, we notice that they move in the opposite direction. So the conventional current is depicted as coming out the positive terminal, whereas the actual electrons are moving in the opposite direction. So conventional current is opposite to the actual flow of electrons. This is because it assumes that positive charges are moving. Electrons are negative charges. And so if the electrons are moving along the wire in this direction, then we can put conventional current as being the opposite. We can assume that positive charges are moving on the wire in the opposite direction. This is the same thing. So we can have negative charges moving to the left, or we can have positive charges moving to the right. Mathematically, these two are the exact same. If we flip the charge, we flip the direction. And keep y'all's mask on. And get that out of your mouth, John. What does it mean to be in series versus parallel? So series versus parallel. So series means no branches in between. Share the same current. Parallel means share the same voltage. And there is branches on both sides. Both sides share same wires. Meaning you can connect them together without running through another resistor. What is the unit for resistance? The ohm. And it uses so an example of series is also like this. We can see that current, if current were to come in, it would go through both without any deviation in the middle. Parallel looks like this. We can see that there's a branch at this point and this point, and we can connect them up using the same set of wires. And note this setup known as a combination circuit, because this is in series and this whole thing is in parallel. So it uses both parallel and series. And most all real circuits are combination circuits. They're good. I don't know, my mom did. I don't know. What's another name for voltage? Electricity would be more closer to current than voltage. So, electric pressure, mostly, so we call this a potential, electric potential, or electric potential difference. So an electric insulator versus an electric conductor. So what's an insulator? And we're referring to electricity or electric in this sense. What's an insulator? So it resists the flow of current. Current does not pass easily through it. Whereas a conductor is one where current passes easily through it. Yeah. That's not electric, that is thermal. No. So air is a very good thermal insulator. A vacuum is the best. So if it was built with a vacuum inside, that would be the best thing. So if you actually removed all the air and insulation, that would be the best insulator. Well, it depends on the insulation. So what foams up is it traps little bits of air inside of it, and that does it. But the material itself is probably less than, I don't know. It depends on the material. I'm not expert on it. So what's some examples of some insulators? And again, referring to only electric insulators. Rubber, plastic, air. Air is a good one. Wood. Wood's a good one. What about water? Water a good insulator? Pure water is probably one of the best insulators. Not pure, it has salt in it. And other materials. Z machine. So this is the Z machine. They take and pump a tremendous amount of electricity through this machine, and they make it run through a single point. So if we look in the middle, there's a little tiny thing. All these are capacitors or giant batteries. This whole thing is to insulate it. They fill it up with water. Look at where the electricity is arcing through, though. The electricity is arcing through the air versus the water. This is because pure water is a very good insulator. And all of this electricity will be hit at a single point, and this is how they study things like black holes, supernovas, because they can generate a lot of heat and energy. So it's called deionized water. You take water and you remove everything but the water out of it. No, because the tap water is not pure. If you take a pure, yes. But if you take a tiny amount of salt, so salt from your skin, as soon as you jump in, the salt from your skin will contaminate the water and it'll start conducting electricity. No, I said that it wouldn't conduct any electricity. So what's some good conductors? Yes. Almost all the metals. Aluminum, Iron, copper. Copper is really good. That's the reason why we use it and everything. Can anyone name some other good conductors? Carbon, such as your pencil lead. That is made out of graphite. Graphite is a form of carbon. It's not really lead, it's actually graphite. So what happens? So if you were to take a balloon and carp it and rub it, and we get some negative charges building up in the balloon due to friction, this is static electricity. Static electricity is the buildup of charges. Buildup of electric charges. That's not due to electricity. It's actually... So when you are sticking pins on the thing, you are melting the plastic on the drywall because of friction, and then it solidified with the pencils attached. Oh yeah. So what is an atom made of? What does an atom have? Protons and neutrons in the nucleus. And what's circling the nucleus? Electrons. So electrons have what charge? And the protons have what charge? And the neutrons have... So, if you had a very, very thin wire versus a very thick wire, which one has lower resistance? Yeah, which one has lower resistance? The lower one. That is because more electrons can flow through it. So more current can flow through it. Versus this one is little tiny. So that's the reason why the industrial extension cords are really thick. They can handle more current going through it. Also, a reason why if you take a bunch of extension cords, or I should say this, which one has more resistance here? A short wire versus a long wire. So this one has lower resistance. So every material resists the flow of electrons to some degree. Short wires, so this would be thin versus thick. So short has lower resistance, and thick has lower resistance. So if you were to add and attach multiple extension cables together, you could actually burn up motors because you increase the resistance the current has to go through. rolling or breaker has to do with the current, how much current. Yeah. So question. So what does resistance do? So yes, you're right. They do resist. They resist the flow of current. But the question is how? The answer is they convert uh, electrical energy into what? What would they convert electrical energy to? Heat into thermal energy. So, it's friction basically, except for an electrical sense. It's like electrical friction. A resistor is an electrical friction. It's going, and just like rubbing or sliding, or trying to grab hold a moving rope, you can get a rope burn. If you were to actually, so how your electrical ovens work is it has a very thick wire and runs electricity through it. The wire has a ton of resistance into it, and so it's going to resist the flow of electricity going through it, and when it resists, it's going to heat up. There will be several Ohm's law questions. For example, 120 volt is applied to a 60 ohm light bulb. What's the resistance of the light bulb? What is the current? So current is equal to voltage over resistance, which is equal to 120 volts over 60 ohms. So 2 amps. Remember, current is in amps. Voltage is in volts. And resistance is in ohms. There'll be several questions like that. And there will be 4 circuits on the test. Yes. Capital A. So, for example, if we have this circuit here, let's let this be 8 ohms, this be 8 ohms, and this be 12 ohms. So this, we can see, is in parallel. We can connect the 2 wires up. So that's in parallel. 1 over 8 plus 1/8. So on bottom, that is 2/8. To divide by a fraction is the same thing as multiplying by the reciprocal, 8/2 times 1, which is just equal to 4. And we can see this is in parallel. So we do 1/1/4 plus 1/12. 4 can be written as 3/12. So that would be equal to 1/4/12, which would be equal to 12/4, which is 3 ohms. So this circuit is equal to a 3 ohm resistor. Another good indication, whenever you do something in parallel, the total resistance is going to be less than either of the resistors. So if it's in parallel, the total resistance will be less than either of the two resistors. 3 is less than 4, and 3 is less than 12. So make sure you know how to do combination circuit. There's 4 of them on the test. Yes. Are there any questions about the test tomorrow? Keep your mask on, Thomas.